Hello and welcome everybody to the webinar, Sampling Asbestos. I'm going to be introducing Kris shortly, who will be taking over and facilitating the webinar, but I'd just like to begin today by acknowledging the Warradungi Aboriginal tribe as the traditional owners of the land on which the AIOH resides. I personally acknowledge the Butamatigal clan of the Durug people as the traditional custodians on which I personally reside. We collectively recognise the strength and resilience of the Aboriginal people on this land and would like to acknowledge all the traditional owners of the land and pay respects to elders, past, present and future. Without further ado, I would like to introduce our facilitator today, Kris Thomas. Kris is the Principal Environmental Scientist and Managing Director of EP Risk Management. With over 20 years experience in asbestos and soil assessment and remediation, Kris was the Project Director at the Barangaroo Crown Sydney Hotel Resort and Sydney Football Stadium redevelopment. Welcome, Kris.
Thank you, Bo. Welcome, everyone. It's fantastic to see such great collaboration between all these key industry bodies here today, especially during National Asbestos Awareness Week and the keen interest that we've got with so many people attending. It's over the 300 mark and it's going up, so excellent stuff. I'll just run through some of the acronyms that are flying around so everyone is in the know with the various organizations on here today. So AIOH, everyone probably knows this one, Australian Institute of Occupational Hygienists, AHCA, Asbestos and Hazardous Materials Consultants Association, of which I'm an executive committee member, ASEA, Asbestos Safety and Eradication Agency, FAMANZ, Faculty of Asbestos Management, Australia and New Zealand, NATA, last but not least, National Association of Testing Authorities. So we've got a stellar lineup for you guys today. We're going to try and keep the presentations short to 15 minutes and we'll keep all questions to the end. We have 4 presentations and if you can just enter the questions onto the chat and for who you would like to point that question to. All right. So first up we have Gavin Chappell, who is the General Manager of Red Ohms Group's Hazmat Division in WA with over 20 years of industry experience. Gavin will be presenting the challenge of collecting representative and sufficient asbestos bulk and dust samples along with case studies. Second, Neil Shepherd. Neil is the sector manager of life sciences at NATA and has been working there for over 25 years in various roles. Neil will be presenting sampling and unacceptable practices such as using sticky tape and the reporting on forms with the NATA logo, which is a very interesting topic. I'm sure we all are keen to watch that one. Third, Yanel Lara is a director of and principal occupational hygienist at AHCA with over 36 years of experience and is a NATA assessor. Yanel will be presenting Australian Standard AS 4964 and an update of current issues. So that's a very good topical presentation that we'll all look forward to. And then last but not least, Dr. Belinda Brown, who's a director of research at ASEA and has a multidisciplinary background in scientific research and management, including applied physics. Belinda will be presenting the asbestos identification innovations, in particular the heat mapping and real-time asbestos identification project that they've undertaken recently. We'll keep the questions to the panelists at the end. We've also have 2 panelists from AHCA and FAMANZ respectively. John Baddy, who is the president of AHCA and the managing director at EDP Consultants. John has over 17 years of experience in asbestos and hazardous materials management. And we also have Samantha O'Callaghan, who is a principal consultant at HIBS with over 13 years experience in asbestos management and also a licensed asbestos assessor. So we've got a very great, strong panel. So please get those questions in and we'll try and maximize the time at the end. Okay, right, first up, Gavin, over to you.
Thanks, Kris. Hi guys, just turning the presentation on. So as Kris said, my name's Gavin and I'm here to talk to you about sampling the good, the bad and the ugly. So what is reasonably practical, or so far as is reasonably practical? This is a term often seen in legislation and certainly asbestos related legislation. Even though it's prominent, there's often a lack of understanding to what it means, but doing what is reasonably practical with regards to asbestos can be crucial in preventing such things as accidental disturbance or exposure. So what does it actually mean? The WHS definition as described here is reasonably practical means that which is or was at a particular time reasonably able to be done to ensure health and safety, taking into account and weighing up all relevant matters, including the likelihood of the hazard or the risk concerned occurring, the degree of harm that might result from the hazard, what the person concerned knows or ought to reasonably know about the hazard, and ways of eliminating or minimizing the risk. Excuse me. The availability and suitability of ways to eliminate or minimize that risk, and after assessing the extent of the risk and the available ways of eliminating or minimizing the risk, the cost associated is not grossly disproportionate to the risk. So essentially what can be done, and is it deemed acceptable, reasonable to do so? So the reason we wanted to highlight reasonably practical is because the following slides all relate to this phrase in what we as consultants can undertake or achieve, and often the bad points are down to a failure to meet with a prescribed definition. So planning. When we talk about planning, this is a typical standard sampling kit. There are a couple of things in there, scaffold towers and EWPs that probably aren't standard, but depending on the scope of works may become standard if it's high level works. So another item here that's omitted is a Hepa Vacuum. Often these aren't included in a standard sampling kit, but usually it's reasonably practical to do so for instances when asbestos gets disturbed as part of your sampling. We want to have some way of cleaning it up. One of the main things listed on this list is wet wipes. Wet wipes are probably one of the most important items here that often get overlooked. Obviously, dust suppression is one of your first controls, but wet wipes can be a second element when controlling the sampling to prevent fibre release and material dropping when you're taking the sample. So planning also includes preparation, which having this fully stocked kit is the best form of. Included in the planning would also be discussing with the client the nature of the site. So to understand the task at hand, this often gets overlooked and the surveyor ends up on site with no prior knowledge of what's going to be faced with. So that preparation is always key to enable the surveyor to take samples suitably. Another thing in planning is how many samples are allowed to be taken. Budget is unfortunately sometimes a prevention of what is reasonably practical to do so. So after planning, we have risk assessment. When we're on site, we want to do what is reasonably practicable, but not at the risk of ourselves or others. So we look at risks other than asbestos. So we know there's risks when taking samples of asbestos, but things such as working at heights, electrics, confined spaces are some of the major ones you come across. Another one on there, which can often be overlooked, is the weather. So if you're sampling outside, high level, weather, rain, wind can be a huge impact on doing things that are reasonably practical. This slide shows a question that we ask on the IP 402, the surveying course, which AHCA facilitate through the BOHS. It's there to try and get consultants to consider issues that they may be faced with when on site. So what precautions should be taken when sampling suspected ACMs in this view? What we want to do is we look enable us to do what is reasonably practical when sampling. As seen in the example, isolations when working near a heat source are suitable measures. Essentially, taking a sample of the roof in this picture is reasonably practicable, but the control measure is potentially just moving to an alternative sample location. However, if it were the flue, the risk may be too great and sampling not necessarily deemed reasonably practical. So as you can see from the photo, there's a car, there's a fire assembly point, and it's probably on a wall, so there's certainly a significant fall from height. So we look at these things to try and get people to think about the other risks surrounding them more than just asbestos. When we're on site, we look at bulk sampling strategies. So it's not just a case of taking a sample of the material that we found. We sometimes have to take more. So for sampling, as far as reasonably practical, it includes a range of factors, and with each one of these comes the challenges. So types of the asbestos, in situ, the homogeneous nature, damage, extent, variations and size of building are all important factors. The overall aim is to collect one or more samples which are representative of the whole material. So for example, extensive runs of pipework in a large building are likely to require significant sampling. So homogeneous is when the asbestos is uniformly distributed, whereas vice versa, non-homogeneous, the asbestos is likely to be sporadic in the matrix of the material. So homogeneous material should be relatively straightforward to select sample locations to represent certainty. However, the non-homogeneous materials pose problems, not just with sampling, but also analysis. Obviously, the sporadic nature makes identification of the asbestos fibres difficult, certainly if an unsuitable sampling location is selected. Slides, there are a lot of suggested numbers around sampling, which is taken from UK guidance. In case you're wondering of that, Australian legislation isn't as descriptive as some of the UK stuff. So where you see the numbers, it's taken from the HSG 264. So spray coating, friable material, it can be sealed or unsealed. You would typically use injection and surface for unsealed and injection for encapsulated materials. It's usually homogeneous. You'd be looking at any changes in colour, texture, repairs, and it's advised that one sample every 25 to 30 square metres is usually suitable. We also look at overspray and give consideration for modern installations over old or previously removed material. Insulation. So insulation, you would use a wet injection. Too much and it could deteriorate, too little, you could potentially get fibre release. So we mark the sample location for integrity, use a core borer. There's a certain technique where we wrap the core borer with a wet wipe and place a wet wipe in it with a bung. And the importance of it is we ensure that we insert it to the full depth of the material. So that shows you, photos show you the core borer and wet injection method. Extensive application of insulation to pipework can cause major challenges when suitably identifying all locations during an assessment, especially if you're limited to the number of samples permitted. As you can see in the photo, the top pipe is non-asbestos, the other is asbestos. So you can see how difficult it is if you're not assessing and sampling each material. You'd usually expect to take one sample every 3 meters, but longer pipe runs every 6 meters is usually suitable. We'd look at obviously the changes in colours, size, textures, any repairs and around the elbows. There isn't, so insulating board, there aren't typically that many challenges representing themselves with insulating boards. The challenges typically come with access to sample safely. But we do see that, or say that one sample per 25 square meters is usually deemed adequate. Again, we're looking at things such as changes in size, colours, or even the fixings. The fixings can be a bit of an indicator of the material. Unlike insulating board, asbestos cement can be very hard, and gaining a sample where an exposed edge isn't available can be difficult to gain a suitable amount. Typically, this is where we see scrapings that are submitted to the laboratory, and the analysis can often lead to results reported as insufficient. So the hard nature of the cement is one of the challenges to get a representative sample. Sampling with pliers with non-serrated edges to prevent cross-contamination is essential. We don't want to have the risk of cross-contamination. In this example, it's floor tiles, but there are many different applications of composites. One of the challenges that stands out is a relatively low content of asbestos that can be found in materials such as this and textured coatings. That's why 2 samples are usually recommended. Asbestos dust, so currently a hot topic. Up until recently, dust samples were obtained with tape or wipes. However, analysis with this media has been removed from NATA scope. Accumulations of dust is preferred methodology. Usually something like a scraper would be used. The number of samples is generally down to surveyor judgment based on the scope of works. There's no hard and fast rule on how many should be taken. The challenges typically lie around dust suppression, as wetting the dust down can hinder collection, and also with the relatively low levels of surface dust in some locations, it prevents the ability to collect a sufficient amount to meet NATA criteria. So, starting with the ugly side of things, these are all attempts at sampling that have been conveyed to me either through rumour, urban legend style, reported to me, or even witnessed, unfortunately. So, sampling with a hammer or throwing rocks at high-level eaves is obviously a very ugly way to sample asbestos. Not to make light of it, but these are things that have been noted in the industry. So that's the ugly side of things. The bad side of things, not so bad as the ugly side, but often is something that's overlooked down to poor timing, general poor practice, but no dust suppression. Sampling at the first location inspected, inspection analysis through small scrapings, taking a sample from the centre of the wall, using a knife or open blade, sampling only the top layer, not sealing the sample point, no decontamination of tools or personal PPE and drop sheets, and often no concern with the remainder of the fabric of the building. So they're the ugly and the bad points. The good points, this is essentially what we should be doing when sampling. So inspecting for differences and variations before sampling. Inspect the ACM for any areas of damage, because the damage could be the areas where it makes it easier to take samples, certainly for things like cement. Otherwise, taking samples from discrete corners, such as behind the doors, behind furniture. Wetting the area thoroughly for surface spray or injection. Use a sharp tool to lever off a sample. Taking sufficient amounts of samples, 3 to 5 centimetres squared in surface area, ensuring all layers of the material included. Preparing the sample point, label the sample point, decontaminate the area, tools, PP, RPE, and sampling should not be carried out where there's an electrical hazard. Also the goods. So when taking any samples, essentially we should be segregating the area. We don't want people in the area so that if something happens, or even if it doesn't, we don't want people potentially exposed. Installing barrier tape to prevent access or signage. Checking you've got the appropriate equipment. Installing a polythene drop sheet to catch any material, donning the relevant PP and RPE, using the wetting agent, using a shadow H-type vacuum for shadow vacuuming, using sample containers, labels, chain of custody, making sure we seal the sample location, decontamination, photographs, recording all the information and risk assessment. So, quickly, because I've not got much time, I've kind of skimmed through them, but that is essentially the best practice of how we take samples. A couple of case studies just to finish off, just to cement home what we're talking about. So in this instance, the client requested a building to be assessed after disturbance to the eaves. The building register listed that the eaves were as negative, with the sample analysis confirming this. Upon review, only a single sample had been taken. No visible inspection points of the eaves were there. Following review, it was established that surveyor had unfortunately unfortunately selected an elevation of the building where the eaves has been replaced, hence being negative. The other three sides of the building were asbestos, one of which the contractor had disturbed extensively. So ensure we check the full extent of the material and sample as required. One last one. So a previous assessment indicated spray coating was present to structural support in a high-rise building. A single sample had been obtained. The sample had confirmed to be negative. However, there was approximately 1,000 meters squared of floor space. It was deemed that due to the age of the building, a single sample may have not been suitable to convey the true nature, so additional samples were collected. Essentially, they were looked at where there was previously asbestos areas underneath the full, and we sampled the full depth of material. The samples came back positive, and it was understood that a new application had been placed over the original asbestos installation. So again, ensure we sample to the full depth of any suspect ACM. So this concludes the good, the bad and the ugly. Very short and sweet. So thanks for listening in, and I'll hand you back to Kris and the next speaker. Thanks, guys.
That's great. Thank you very much, Gavin. That was excellent. We've got quite a few comments on the chat as well, so we'll share the chat at the end and we'll download the chat. So there's some good comments. Okay, Gavin, if you want to stop the share, that'd be great. And then over to you, Neil.
Thank you, Kris. Fingers crossed it works. Now I can see you, but I need to get there. And okay. Can you see the screen?
Yes, we can.
Excellent. All right. Well, thank you very much, everyone, for coming today. I think I saw 370 odd people in the chat before. That's an excellent turnout. I know this is being recorded, so you can, the rest of the registrations, I think it's up to 700, can have a look at this later on. Thank you for the organisers for inviting NATA to speak today. I'll start my presentation. I'm just going to go through a few issues we have around sampling. I can get the slides to advance. I need the keyboard, not the mouse. Sorry, excuse me. So the first thing I'm going to talk about is we revised our supplementary accreditation criteria. Now, for those of you who don't work in a NATA accredited laboratory and not familiar, the supplementary accreditation criteria are what we publish in order to sort of explain to the accredited facilities the things they need to do in order to be accredited. So occasionally we revise those. And that particular document, that was quite an effort. I think probably we had 3 iterations, and it took a couple of years of feedback. So we seek stakeholder feedback, and we review each and every comment and publish our decision as to whether we accepted those comments. So we're trying to make sure that our documentation reflects industry practice and the stakeholder needs. So just in that, one of the interesting things that we did was to talk about sampling plans. Now, previously, we've always had sample collection, but we encourage sampling plans. NATA can't actually make anybody be accredited for anything. It's actually driven most of the time by the stakeholder demand. And so I've got the word encourage there. You'll notice the important words in my slides are in orange. So just to focus your mind. So we encourage sampling plans. The reason for that is that if you can have all the best in the world, you can have all the best equipment in the world and all the best trained staff. If your sample isn't representative of where you collect it, of where you collect it from, then really you're not giving your customer the best result. So whilst we don't have a lot of facilities that look for sampling plan, we can offer that accreditation, and it is encouraged. So if you are out there using the services of an accredited laboratory, please think about whether or not you would like to see accreditation of sampling plans in those facilities. Just another note there that accreditation isn't restricted to AS 4964, which is the current Australian standard, or to the NOSH if you're talking about air sampling. We have included a number of other documents in there. I think one of the issues is, of course, that legislation here refers to 4964, but we can offer accreditation to other documentation, including, I've got a slide in a minute, including ISO, etc. but really it's down to fit for purpose which methodology you use. And again, just a nod there to the end, accreditation is customer driven. And if you want to reduce your risk of samples being taken that are not representative of the source, use a facility accredited for the development of sampling plans as well as sample collection. So probably this is probably the most important thing people are interested in me saying today. I noticed a bit in the chat there that around tape. It was interesting to me a while ago to notice that we were getting these comments around adhesive tape and wipes, and so I looked at the standard. I'm actually on the standards committee for CH31 for that standard, and in discussion with that committee, we're of the opinion that adhesive tape and wipes aren't actually part of the scope of that standard, and as a result, you really need to use it. You need to validate your method yourself. We're not precluding it. We encourage method development. But I think you might struggle actually to develop a method using adhesive tape or wipes in exactly what you're doing. That's the plan of developing a methodology around that, and the validation of that methodology really needs to be considered. Because I have in the past, as I said at the start, as the introduction said, I've been working for NATA for more than 25 years, and often I will see data submitted, and a lot of thought of work has gone into it, but actually the premise of the validation protocol in the first place is flawed, and you can't really determine whether what's been sent in is actually meaningful. So be very careful if you are thinking about validating an adhesive tape or wipes method. What are you doing, and what are the results going to be used for, and how would you actually demonstrate that? Do you need to compare it against 4964? Is there another method you can compare it against? Are you doing presence, absence, or counts, etc.? All those questions need to be considered. Now, a word of caution here: NATA doesn't endorse any of these methods, but I thought, seeing I've given out instruction around dust and 4964 and adhesive tape, I'd have a look and see if I could find some other methodologies. So there are quite a few ASTMs. There's the NIOSH method and an OSHA method for various things. And again, I'll say none of those things are endorsed by NATA, but there are published methods there. There is an adhesive tape method there, I noticed. I haven't looked at it, but for those of you who are wondering what else might be used, then maybe some of those might be of use. So the challenges of analysing dust. Now, remember, I'm not a subject matter expert, so I'm really sought this information from our Accreditation Advisory Committee and other technical experts in the field. And as you can see, there are 4 points I've got there. The settled dust is predominantly well below the optical resolution, so I suppose there you have difficulty maybe knowing exactly where to put your tape, and how much area do you actually sample in order to get a representative sample. If you're using a wet wipe or some other swab type exercise, the fibers on that may interfere with the analysis. It's difficult to know until you start looking at what's in these wipes and in these swabs, exactly how they might sort of represent when you're doing the analysis. The third one there, the polymers, I've looked at that a few times, and I've seen a few papers on this issue around whether or not whether you heat the tape up or whether you just sort of use the tape stuck onto a slide. Both of those things seem to be problematic, but I'm not going to investigate too much further with that. I think, we really, NATA's premise around the sort of 4964 is it's not in the scope. So we're not saying you can't do it. We're saying that you can't claim 4964, and if you're going to do something else, you need to use a valid method. So just whilst I've got a captive audience, I'd talk about collection of air samples, because again, that's another issue we have. So we've got accreditation for bulk and for fibre counting in air. And there's a few issues there that really are pertinent to what goes and often cause problems when we do assessments. So the first thing is around the pumps, making sure that you check the functioning of the pump immediately prior and post the sampling period. And if you're using a third party or other staff other than actually employed by your facility, you need to actively supervise those activities. Now, what does that actually mean, actively supervise? You can't be there every day because, of course, you might as well do the work yourself. but you have to have a process of being able to observe what goes on, visit them occasionally, train them, make sure they know what they're doing, because ultimately you as the accredited facility, and your customers are expecting this, you are responsible for the work they do, and the results, the quality of the results is related to how competent they are. It's somewhat difficult to sort of know on an ongoing basis exactly what's going on, but if we look at the pandemic, we consider that what we've learned and what we're doing today, you know, we would have once upon a time, we would have all gathered in a room, had some party pies and chatted around this stuff when I would have been standing at a lectern, but now I'm talking to you all with the power of Zoom. And I think if you've seen our assessment activities, what we do now is sort of have a remote assessment activities during the pandemic and the lockdowns. And you could use that technology. There is no reason why you couldn't get some virtual means of observing what's going on the remote activities that occur. The other thing there is around the volume measurement itself and how it's reported. So it's very important that the concentrations can only be included under the scope where the accredited facility is accredited volume measurement. So that is, you do the calculation, so you know the flow rate of the pump and it's calibrated, and so you know that that's accurate, and you also know the time in which the pump ran for, so that you then can calculate the volume that went through the filter. And all of those things have to be under the full control of the accredited facility. You can actively supervise other parties, but again, you've got to make sure that all of that is under your control, and you can demonstrate that when you have an assessment. Just on field sites themselves, as we're talking about collection there. So the definition of a field site is really it operates for a project, a single project, such as the demolition or the refurbishment of a building, or some other activity, some sort of soil, large scale sort of soil, I won't say refurbishment, what's the word I'm looking for? I've forgotten the word. So the soil is being, I can't think of the word. What is the word? I'll move on. So you've got a process that's going on for a certain period of time, and it's better to do the sampling and the work on site, so you actually position your staff there for this duration of this project. And importantly there, again, you need to look at staff training, monitoring of competence, the oversight of equipment functionality, including any calibration that needs to be done. And these field sites need to be visited. Now, that's periodically. We realise you can't go there every day, otherwise wouldn't be any point in having a field site really. So you have to have a process in place that the facility has supervisory oversight of the personnel at that facility. You visit, and when you visit, you keep records of what's going on. So we allow collection and return to the base site, and we allow collection and activities in the field, so to speak. Now, I'm just about finished, so I didn't have many slides actually. I thought I'd put that up there because often I think I'm not seen as Kurt. I'm one of the other two, but really I think we're all in this together. It's a difficult exercise sometimes to sort of explain to people why we make these decisions. And I know there's been some sort of negativity around the decisions with wipes and adhesive tape, but I've got some questions coming up at the end, and I'm happy to continue the dialogue. But I'll leave it there and say thank you for your attention.
Thank you, Neil. That was excellent. And yeah, we've got some further questions coming in. So yeah, if you've got any more, please fire them through, and we'll try to get to them at the end. Right. Okay. Neil, if you could stop sharing your screen, and I'll hand over to Yanel.
Stop sharing. Hello.
Hello, everyone. Hope you're all well. I'm just going to share my screen here. Hope you can all see that. Is that the case?
I can only see yourself, sorry.
Oh, okay. I'll try again. Maybe it got muddled up with here we are. Is that better?
Yes, we can see that now.
Wonderful. Okay. Thank you, Kris, for the assistance, and also to Neil and Gavin. I'm talking to you as a hygienist who is representing the AIOH at the Standards Australia CH31 Workplace Atmospheres Committee. And I've been asked to provide a bit of an update on the old Australian Standard 4964 on the qualitative identification of asbestos in bulk samples. A bit of a review and a bit of an update on this. So I hope to share some information there with you. As you all can tell, 17 years ago, that Australian standard got released. So it's the major, if not the only method that NATA accredited laboratories use for the identification of asbestos in bulk samples, and not just commercial samples, but also dust, soils, ores. So it covers quite a big area. Now we've always had some issues, and being a NATA assessor, I've come across these in trying to assist labs to try to report correctly on these, because in a way it's been found that it's a confusing standard, particularly with the reporting side of things. And particularly with the non-homogeneous samples in terms of soils and dusts. One of the main areas here is the fact that some labs are not actually providing a factual description of the asbestos or the asbestos containing material they find amongst the dusts and soils and ores. It has been a very useful standard, but it is now dated and in need of improvement and clarification. And I think we've learned a lot from using it, and so we should take that experience on board to improve the standard. Now, as hygienists, a few of us got together and had discussions about this Australian standard since about 2017. So it's been taking a long time to get to where we are now, and I'll let you know what that is, about updating the standard, making sure that we've taken everything that we've learned on board and put it into a document that is much more friendlier and covers areas that it hasn't picked up on or we can do better. With the review that we undertook, we considered a number of items. The main ones being these ones that I've set out here. The fact that it should be developed to be more prescriptive, for more guidance for laboratories. A bit more detail on the actual analytical process that we need to follow through PLMDS. More flowcharts so that the decisions are made much more clearly. The reporting of results, perhaps on making that a little bit easier for labs to understand and follow. And considering the fact that we're also now looking at aggregates and minerals samples and putting them into the picture about how to deal with those. But also thinking that PLMDS is really the primary technique that we have for identification because of the fact that it's simple, low cost, it's relevant, and the detection limits that it provides. So just updating it doesn't mean that we need to discard PLMDS. We just need to make sure that the actual standard serves us better. So we considered the use of ISO 22262-1 air quality sampling for and qualitative determination of asbestos in commercial bulk materials to consider during the review. Early discussions we had on a gap analysis by that small group of hygienists, and we identified a number of areas that needed addressing, that needed to be looked at. So the main points that we came across, well, first of all, is that the ISO standard only talks about commercial bulk samples. So it doesn't deal with minerals, ores, dusts in the same way that the Australian standard does. Sample collection is actually mentioned briefly in the Australian standard, but it's a little bit more expanded in the ISO standard. The definitions on the morphology of asbestos and other mineral fibers is something that goes into a little bit more detail in the ISO standard. Things like acicular or asbestiform, amphiboles, cleavage fragments. So these things that get picked up in the ISO standard. The other thing the ISO standard, for example, doesn't talk about is the non-commercial preparations of the RI liquids, and a little bit about the calibration of these as well. As you know, the commercial brands get a yearly calibration, whereas the homemade ones have a 3-monthly calibration frequency. Now, ash in temperatures and duration is also something that was quite an eye-opener for me. The ISO standard refers to temperatures of 485 degrees Celsius for 10 hours, as opposed to 400 degrees plus or minus 30 in the Australian standard, with a duration that typically is around 2 hours, 1 to 2 hours. It depends on the material, obviously. So a big difference there. Treatment of the soils, aggregates, dusts, minerals, particularly with soils. Sieving is a process that's done in our Australian standard, but this is actually not covered in the ISO. Main reason being that it's talking about commercial samples purely. Trace analysis, there is a sort of limited address of this in the ISO. It does talk about doing mounting of small amounts of the material onto slides and scanning them, but certainly well prescribed in our Australian standards. And then we have electron microscopy being addressed in the ISO standard. So it still talks about PLM, DSB in the primary method, but it also recognizes that there are circumstances under which electron microscopy work is crucial. Things like fibers which are below the resolution of the light microscope, less than 0.2 microns. Matrices that adhere very strongly to the fibers and then therefore are obscured by that matrix when you're trying to look under the light microscope. And the fact that it actually, electron microscopy allows us to do that confirmatory process when we cannot identify the asbestos fibers unequivocally, particularly obviously in the case of amphipholite, tremolite, and actinolite, the less common varieties. So another thing that I haven't listed there is the fact that despite being a qualitative technique, ISO discusses a little bit about visual estimates of the asbestos mass fraction. But it's important to remember the ISO standard only talks about commercial samples. So that estimation becomes a little bit easier. It becomes much more difficult when we're looking at things like soils or dusts, when it's actually the asbestos is a contaminant rather than a material that is meant to be in that particular matrix. So all in all, I think quite a number of points where the asbestos, the Australian standard differs from the ISO standard. But overall, it's a good match. We just need to see if we can work out a good blend of these two to come up with a good document. So the update that I have is that, like I said before, there is a committee in Standards Australia, which is CH031, Methods for Examination of Workplace Atmospheres. The committee formed a working group at the start of the year to develop a new Australian standard. Now, ISO 22262-1 forms the basis of this. It got voted as the standard to follow. But we need to review it to provide an Australian content. So the working group has been developing and reviewing drafts, and that's what we're still currently doing. We've actually changed a project manager for that working group, so we're waiting to get back onto it with a new, to work with a new project manager for this. We hope eventually we'll have a final draft to be submitted to the CH031 committee for them to take on board and review further, with eventually having a draft for public comment to be released. So I think it's important that you're alerted to this. I'm not sure what the time frame is, particularly since it needs to go back to the main committee. But you know, please become informed of when this is going to happen in terms of those comments when the document becomes publicly available, so that we can gather as much information from everyone about making this a much better standard. So I hope that sort of gives you a bit of a review and an update of what's going on with 4964. And if you've got any questions, please ask. So I shall leave it there. And thank you, Kris.
Thank you very much. That was excellent. And we'll all be looking forward to having a read in the near future, no doubt. Okay, excellent. And thanks for stopping the share. Right, and the last presentation of the day, I'll hand over to you, Belinda.
Thanks, Kris, and good afternoon, everyone. All right, today I'm going to talk with you a bit about ASEA and our recent work on technology. Next slide, please. So who are we? The Asbestos Safety Eradication Agency, also known as ASEA, is Australia's national agency, and we coordinate the National Strategic Plan for asbestos management and awareness. We're not a regulator, so we do a lot of work in the asbestos awareness space, promoting effective and safe management, and the ultimate aim is to prevent exposure to asbestos fibres in order to eliminate asbestos-related diseases in Australia. All states and territories have agreed to the plan, and it runs from 2019 to 2023. I look after the research area, and that supports the implementation of the plan, as well as our work with a range of stakeholders. The plan is available on the web, so I encourage you to go and have a look at our website. Next slide, please. All right, so part of our research is also looking at the legacy asbestos volumes in Australia, the stocks and the flows. So we recently updated this model, which was first created in 2015 with Blue Environment. And currently, state of play, our best estimates nationally, approximately 11 million tonnes of asbestos was produced in Australia. So that peaked in the 1980s. Currently, estimates are approximately 6.4 million tonnes of asbestos remaining in the built environment. So, of course, when you're thinking about residential, what's left in residential homes? That's information about that is pretty disparate, dispersed, and it's not all together in one place. So the rule of thumb, of course, being asbestos is in 1 in 3 homes nationwide. But looking now, where asbestos is in the residential environment, its location and density, its presence and absence. We've been looking at what sort of solutions technology can provide to help give us an evidence base or a national picture, what's remaining. Next slide, please. All right, so yes, we have a project called the National Residential Asbestos Heat Map. And that is about creating an evidence base and a national picture of the likelihood of asbestos being present in the residential environment. So it uses a range of inputs or information and data, as well as machine learning, so which is a type of artificial intelligence. So how you can help fill those gaps and create a national residential asbestos heat map. So just to give you a bit of background, we have done a pilot project on roofing. We are now looking at asbestos data from the residential data across the board, as well as proxy data. So building age, ABS surveys, major national data sets like Nexus from Geoscience Australia. So ASEA has now engaged Tetra Tech Coffee to work with us to develop the National Residential Asbestos Heat Map. And the heat map is designed to inform governments where the legacy asbestos is likely to be and how that can be used in planning for targeted communications, as well as in situ management and prioritise removal. So really it's trying to find ways to bring what we have together and use machine learning to create some mapping. Right, next slide, please. Right, so as I said, we started with looking at roofing, and we developed a pilot study to look at bringing together what satellite data, aerial data, machine learning and AI can help provide. So there's been large advances in general in the cost and availability of satellite and aerial data, and also the classification and machine learning of that data for various purposes around the world. And so it has been tried for roofing, asbestos roofing in Italy and Hungary and other countries in Europe. And so we tried for the first time in Australia to apply some of these methodologies fit for purpose for the Australian context, working with UACS, which was the consulting company who developed the roofing pilot study with us. So what does it do? It looked at urban analytics first, so like housing age and other socioeconomic data, so the CEFA indexes, to give a bit of an urban analytics filter in the first pass. Then the study looked at areas of interest. So we wanted to get a selection, so metro, peri-urban and coastal, for example, around Australia. And then of course, the processing of the high resolution imagery, both satellite and aerial. That was all put through a machine learning and AI computational model. That was a training data set was created, about 4,500 properties to get that training data set. And then to validate, so we had an asbestos assessor looked on ground or with Google Street View to look what was popping up in the model and what was being observed on the ground to validate that. So once that was all underway, that gave us the ability to run the model fully and come up with some results. Next slide, please. So this is a video from UX Consulting, so I'll leave that for you to watch that. And as you can see, some of the quality of the imagery and detecting Super 6 asbestos. So as you can see, it's picking up roofs and outbuildings as well. All right, and here we are in Melbourne now, Mornington Peninsula. And Western Australia. Yes, as you can see, that's a nice summary of the pilot study and what could be detected through machine learning, as well as a range of analytical tools. Next slide, please. That was just starting again. All right, so just to give you some examples from Western Sydney and from Queensland, just to show you. So the Western Sydney study is on the left screen, as you can see. And the number of hits showing quite a high density in Western Sydney, around 2,000 properties with asbestos roofs in that study area. So that was around 94% precision study accuracy with the machine learning. So there's a lot of power there, as opposed to someone going through and visually picking it, or going on to the street and assessing it. So of course in Queensland, of course, this is an example showing the likelihood and the high to low. So on the left-hand side, of course, you've got the high and in the yellow, and blue being lower. So again, it's another tool to analyse, the high probability of where asbestos roofing might be. And so, of course, we hope to extrapolate all that sort of information and all those sort of options through a national tool of the whole of home or urban, all of residential information. Thank you. Next slide. So what else can remote sensing and technology do? Well, from Google Street View alone, you can see here on the right-hand side, it can pick up asbestos cladding as well. And we thought this is particularly useful in remote areas where it's very hard to get in, and obviously with COVID recently, it wouldn't be desirable necessarily as well. So we're working with the National Indigenous Australians Agency and consulting with them on options going forward for what we could do in remote and Indigenous areas. Next slide, thank you. All right, so now just to give you a bit of a summary of another project that we're doing with the Department of Industry. So the Department of Industry has a program where other federal government agencies, such as ASEA, can apply and present a challenge. So ASEA presented, of course, the Asbestos Challenge and was successful. And through that challenge, up to 5 small to medium enterprises will be provided with grants for 3 months to test possible technologies for asbestos. So our webinar for that is still on the Department of Industry website if anyone would like to see more details there, or of course can contact me as well. So through BRE, what were we scoping as far as technology solutions? Looking at ways to have real-time testing in situ, in air, for ACMs, or software, data, better safety systems, apps, registers, anything in that e-system data space where you can link things in real time and just make the job easier and faster for everyone. Okay, so we're hoping very soon that we'll get some results from this, and that will of course be on our website as well as the Department of Industry website. Next slide, please. So was really pleased to share with some examples in our projects with you today. Very interested in any linkages and technology you may have through your work and projects for air, for ACMs, for apps or e-systems, soils, or remote and Indigenous areas. So please feel free to contact me. And I'll also direct you, of course, as always, to the Asbestos Safety website, where we all have lots of news and events being shared there also. All right, well, thank you, everyone.
Thank you, Linda. That was excellent. And it's fantastic to see technology is finally getting into the asbestos industry. Sometimes we're very much light years behind the technology in the real world. Yeah, so there's a few questions. We'll probably just finish the presentation there and get the panelists on, so everyone's on the gallery view. Guys, could you jump on? Okay, Neil, there's a question that was sent previously, and I think we've had that email through. Please discuss forensic gel lifts in their relation to the ugly practice of using sticky tape for sampling asbestos dust. And there's also a very similar question that, can there be an update on the decision by NATA to not allow adhesive tapes, wet wipes to collect potential asbestos fibers? And what is going to be the accepted method?
Okay, so I think, thank you, Kris. I think I can answer both those questions at the same time. I've actually never heard of forensic gel lifts to be used in this process, but I suppose if they're sticky, they're being applied to a surface. In all of these things, it's around the validity of the method. Can you demonstrate that the method does what you say what you need it to do? So you really need to think, okay, I'm using some adhesive properties of a material. It's applied to a surface. What is that doing? What am I, when I get those fibers off, or how I process those fibers, how can I demonstrate that that is a valid result in relation to the surface at which the adhesive material is applied? And I think that's the problem, how you actually go about that. NATA can't answer that question. It's terrible. We say, you have to have a valid method, but you're the SMEs. You are the facilities, you are the experts in this field. You have to think about the limitations of what you're doing and look at trying to make sure your methodology gives a robust and repeatable answer to your customers.
Okay, great, excellent. All right, Yanel, there's one for you. What's the time frame for the revised standard? Probably quite hard to give a finite time frame on that, actually. But.
Yes, there's no time frame that we have been assigned, as far as I'm aware, and I think there's still a little bit of work to do, particularly since these ISO standards that are sort of somewhat related to what we're doing are actually being reviewed as well, and some of the committee members are actually trying to participate in those discussions just to see what direction they're taking. We're still in that working group stage, so it hasn't even gone up to committee level. So I think it'll be months. Yeah.
In the midterm, we'd say, not immediate. Yeah.
Correct.
Yeah. Okay, great. And is there any plan to have any inclusion of ISO?
Yes. So I think it's the way that I describe it is ISO standard with Australian components.
Right, just married together. Yeah, great.
Yeah.
All right, great. Belinda, there's a question here for you. Can the AI detect the roofs that have been encapsulated and painted? Is it been ground truths at all? Where there's a painted layer?
Oh, with the roofing. Yes, look, it's not my understanding in particular. I think that would take another study as well for that.
Okay.
So yes, primarily it was the Super 6 detection. So there's also room for slates and things like that as well.
All right, okay, yeah. It's a similar question. Is the AI based on roofing discrimination purely based on the visible imagery, or does it utilize regions in the electromagnetic radiation or hyperspectral range.
Yes, it's been tested for hyperspectral.
Okay, great. All right, beautiful. Let me just jump into the Q&A. Here's a technical question. Collecting samples is not the same as undertaking precise volume measurement in the field. Is it appropriate to use non-NATA personnel to undertake these test measurements?
That's a question for me, is it, Kris? Sorry.
Yeah, so yeah.
Yep. So the issue is that we understand, so we accredit the facility and the staff employed in that facility for their competence. But we understand that this is a large continent, and to facilitate more quick results, and you may have sort of workers waiting for clearance or something to get onto a site. Rather than ship the samples back, we have said that you can allow staff at that site to operate under your management system, but you have to maintain their, you have to manage their competence and supervise them. Now, that is possible, but of course it requires some logistical exercise. You've got to go there, you've got to train them, you've got to make sure their equipment's being used correctly. So it is possible, but I think that it does come with its own sort of challenges, and you are beholden on them to do the right thing when you're not around. So I mean, you have to make sure that you have engaged people who are competent and are willing to do the work that you're telling them to do.
Okay, excellent.
Can I just jump in there? I guess further to that point, I think it is quite important for us all as hygienists and professionals that we are ensuring that people that are putting pumps out are independent and actually doing a job that's representative of the flow. Because certainly, obviously in NATA's position, it's really important to allow rural communities and smaller consultancies to be able to do this kind of work across Australia. But certainly in the industry, we've heard of asbestos removal contractors putting out air monitors at their own sites and things like that. So obviously us as a community, and it's great to have forums like this to try and stamp out issues like that, because it's always really important that we raise these issues and make sure that it's not happening.
Good. Belinda, here's another AI question. Has the AI mapping been applied to other ACM, not just fiber cement, bitumen roof membrane coverings, etc.?
So the asbestos roofing was the first pilot, the first test. Right. So that's what we started with. So what we're doing now for the national heat map, that will be one data set, but we'll be bringing in a range of direct observations from housing data, including public housing data, and a range of proxy data sets, like I mentioned, Nexus or the ABS for building age. So there's a lot of scope with AI for the cladding and the roofing going forward. Fencing, look, there is a lot of scope there.
Okay, this is an open one for the panel. What is the panel's view on delayed start air monitors? How do these fit into calibration of immediately after start and before end? Anyone?
I'll jump in. I don't have that much experience with those kind of pumps, but I guess you need to look at it from a holistic perspective. And if you're putting the pumps on and they're just on time, as you can hear of people that put it on, they only visit a site once every 24 hours. So what are you monitoring for, and is that actually suitable? Because there's nobody actually overseeing the works that are happening to understand what the results mean, because you actually haven't seen any of the activity. So I guess it depends on what the purpose of your monitoring is.
Yeah, true. Yeah. Hey?
I'd like to add just quickly, I guess it's one of those methods that needs to be validated, and if you can show that you can validate that method in terms of using the timer, then potentially it's something that can be done. Wouldn't go away from it. A lot of the time we are doing air monitoring where a consultant will attend site, set up the monitors, and then return to site at the end of the day. So they won't be observing the work the whole time. So if you can have a validated method in which the time where it can be used and it's shown to be used appropriately, then it can be done. And I understand that NATA is in agreement with that as well.
Thanks, John. Okay, here's one for Yanel. With the review of the standard, ID for chrysotile to chrysolite only is based on traditional types of asbestos used in building products in Australia. Given asbestoform minerals that we come across with NOA, naturally occurring asbestos, and with some building products paint with tremolite, for example, and that the methodology would be the same. We already have refractive index oil polarizing light microscopy and dispersion staining. Would this be an easy addition to the standard so that we have the RI for the tremolite, actinolite, etc.? Would that be an easy addition?
Well, the treatment of the less commonly found and NOAs and all of those minerals will need to be the same way as it is at the moment. So it'll be being able to unequivocally identify the three main types, your chrysotile, your chrysotile, your amosite, with the others reported as unknown type until you can use another confirmatory technique, and that will be the TEM and SEM that will form part of that standard. So there'll be the complementary methods to be able to, yes, all 6 varieties to be identified.
Excellent. Okay, another question for Belinda. Is your mapping information making it to local government disaster management organisations, especially in the areas of North Queensland where cyclones are common, and for disaster management consideration, cleanups, you know, bushfires, etc.?
Yes, thanks for the question. It is a absolutely potential application, and I have been speaking to the Australian Research Data Commons, which had some funding from the federal government for improved bushfire planning. So yes, we're looking into that, and look, there are a lot of things that came out of the last big bushfires of how we organise and share this sort of data.
Okay, great. That's about it, I think. Yeah, there's a couple of curly ones, but we'll, yeah, if there's nothing else, I'll hand you back to Bo.
Thank you so much, everybody. This webinar was fantastic. It was great to see everybody from the industry come together around asbestos and have this chat, and hopefully this is the start of many more. I would just like to say thank you to each person on the panel. I would go through you all your names. Belinda, thank you so much. I know that we had a few technical things happening there, so I know you went out of your way, so thank you so much for that. Yanel, thank you again. Sam, John, and Neil, thank you. And Kris, of course, to yourself. Thank you so much for facilitating this. You did a fantastic job, and we're very, very grateful. That's it for now, everybody. And yeah, thank you for everybody that came and attended. And if hopefully, in the future there'll be a few more of these to advertise, and we can catch up again.
Yeah.
Thank you all.
All right. Have a good evening, everyone. Thank you.
Great.
Thank you, everyone.
Thank you.
Thank you. Thank you for your attention.